Welcome to Milak Online tutorial. Before us, we'll be looking at how to derive the Boyle's law general equation for gas trapped by column mercury. Okay, now looking at what's on the board here. Now here is a tube. Now where a particular column of mercury traps in a gas. So here's the gas, the gas, the gas. Here's the mercury, and the mercury. Now L here represents the column the gas occupied, and X here represents the column of mercury, or probably the length, okay, as it is. Alright, now let us now first of all look at what's Boyle's law. Okay, now by the definition of Boyle's law, now Boyle's law states that the volume of a fixed mass of gas is indirectly proportional to the pressure, provided that the temperature remain constant. Okay, we can rewrite this as saying that V equals K all over what? P, and where our constant is what? P and V. Now in a case whereby we have more than one system, so we can have it as P1 V1 equals P2 V2, probably 3, then we can move forward by writing equals then P3 V3. Okay, now that we've established Boyle's law, then how then do we derive the general equation that governs the gas being trapped by column of mercury? Now let us consider this. Now this is the vertical component of the tube, which means it's facing vertically. Now this is the inverted aspect of, so let me just probably write it here. Now this is vertical. Okay, here let me say vertical here, vertical, then this is inverted, and this is horizontal. Okay, now in this case, now let us start with the vertical. Now the atmospheric pressure exerts force in this direction, and take note that the pressure exerted by the gas here acts upward. Okay, all right, and the pressure exerted by the column of mercury also acts downward. Okay, now for the system to be balanced here, we now have, now let us represent P, capital P, as the atmospheric pressure. Now here small p sub g as the pressure of the gas. Okay, and let us represent the column of the mercury as X. Okay, so in this case now, okay, in this case now, and let us also take note that this column is same in all the tube. Okay, now to this end here, now we can now say that P, which is the atmospheric pressure, plus the column of mercury, okay, minus the pressure of the gas equals what? 0. Okay, to this end here, we can now say that P, and which means that atmospheric pressure is plus X equals Pg. Okay, so the pressure on the gas here is the sum of the atmospheric pressure and that of the mercury column, or I'm sorry, the column of the mercury. Okay, now let us now move to the inverted. Now in this case, the atmospheric pressure acts upward here. Now take note, the column of mercury also acts downward, and that of the gas also acts downward. Now you can see that the two sum together, acting opposite to the atmospheric pressure here. So in this case now, we can now say that the pressure of the gas now plus that of the column of mercury, X, minus the atmospheric pressure equals what? 0. So this end we have Pg, then plus, okay, in this case now we can now say this is making Pg the formula. We now have that P minus X. Okay, all right. So in this to the third one, which is the horizontal. Now the atmospheric pressure comes in this direction. Now the gas also goes in this direction, and for the mercury it acts downward, which means it has little or no extraction on the trapped gas. So to this end here now, since the pressure of the gas act opposite to the atmospheric pressure, we can now say that Pg minus the atmospheric pressure equals what? 0. So to this end, the Pg, which is the pressure in the gas, then equals the atmospheric pressure. Now that we've gotten the pressure of the trapped gas for the vertical column, then the inverted column, and the horizontal. Okay, now let us now apply to this. P1 V1 equals P2 V2. Take note, we have three systems here. We have equals to P3 V3. Okay, now but in this case, now let us look at here. We've ascertained the pressure. Okay, now the volume of the trapped gas. So take note that the length of the column of gas is also similar to the volume occupied. Okay, so we can say this is L1, now this is L2, and this is L3. Okay, so to this end, take note that it's same thing as the volume. So V1, now this one too equals to V2, and this is equals to V3. Now to this end, for P1, for here, we now have that P plus X, now the volume L1. Then for P2, which means here you have P minus X, then L2. And for P3, now our P3 is the same. Here we have what? P, then our volume also be what? L3. Okay, so to this end, we can now conclude that the equation, the Boyle's law equation, the general equation for gas trapped by a column of air equals to this. Alright, so as simple as that. Alright, if you love what I've just done, can you subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.